All right, folks, here we are. We're going to go through worksheet D, first of the probability worksheets. And I'm going to post my video, and I'm also going to post Zach's. He did the first couple pages while I was making dinner a little while back, and you can compare the two of us, see who's a better teacher. So this is basic probability, so it'll go pretty quickly. First one is a bag with marbles. Tells you how many of every color, and you're picking only one marble, and that pretty much goes for all of these questions. You're only picking one item at a time. Later in the chapter, we'll get into 2 items or 3 items or 4 items at a time. So probability is always, the total number of ways over the number of ways to get what you want. Oh, I didn't leave myself nearly enough space. Number of ways to get desired outcome, right? Oh my gosh, that's terrible. I think Zach's already in the lead. Look at that. Okay. So how many red marbles are in there? There's 10 red marbles. If you add them all up, there are 62 marbles. Add them all up, 64 marbles. Just adding up all of these numbers. This kind of goes for all of probability. It is best if you reduce. Is it totally critical and essential? Probably not. You also need to be able to recognize, like on a multiple choice question, they might write it like a decimal like this, or they might even write it as 15.6%. And I'm not going to do that for every single question, but you just need to be flexible in your thinking. It can be written as fraction, decimal, or percent, and they're all totally fine. Excuse me. Next question, black or white. These are those two. So there's 19 marbles that qualify for what we're looking for. 19 out of 64 does not reduce. One more time I'll do this. So on a multiple choice question, it might say 0.296, or it might say 29.6%. So red or green, it's those two. So 22 out of 64 divided by 2 brings you to that, and I don't think that reduces. And I'm not going to go through the decimal approximations every time. If you want to do that, you certainly can. I know some students prefer percentages because their mind understands that better. Red, green, or blue? Well, think smarter here. We already have red and green right here, 22. So I just need to add blue onto that, 15 more. So that's 37. And that doesn't reduce. Here, not white, you're going to see notation like this perhaps. White with a C like that. That means not white. And I like to just take the total of 64 and subtract how many white ones there are. So rather than adding up everything that's not white, just take 64 minus 12, and it's a little bit more direct or quicker. So there's 52 out of 64. That one would reduce. I'll let you take care of that. Not white or black, meaning the way it's phrased, these kind of have to go together. You are not picking a white and you are not picking a black. So in my list up here, I'm ignoring these two. I cannot pick those two. So therefore, these 4 colors are the target colors or the desired colors. And when you add those up, 10 plus 12 is 22, plus 15 is 37, plus 8 is 45. And 45 out of 64. I do not think that one reduces. All right, next question. Gerald's TV has 120 stations. At 8 p.m., 42 stations are showing commercials, 18 sports, 25 are showing movies, 7 news shows, and 13 comedy programs. 12 dramas and 3 sales programs. Lovely. Look at this. Old antennas and TVs. Look at that. These days, you're like streaming everything. All right, we're going to pick one station at random. Again, everything, this worksheet is one station or one event at a time. Choosing a news show, well, there were only 7 news shows. If you add up all the shows, it's out of 120. Commercial shows, there were 42 of those. Okay, this one reduces, this one does not. So 7 is prime, so I'm done with that one. 42 out of 120. If you want, go for it. And that's 35%. If you would like to do that, that's totally fine. If that resonates better with you. A comedy or a drama, just add up comedy and drama. That's 25, I believe. 12 dramas, 13 comedies, that's 25. Okay. D, you have 3 categories, sports, movies, or news. And when you add up those 3 categories, that's 50 shows, which is just 5 out of 12. Just chop off that 0. Not a sales program. So again, this could be written like this. Like, notation is very big in this chapter. Could be written like that. Probability of sales with a little c as an exponent. That means probability of not a sales program. So there were 120 programs. How many of them were sales? 3 of them. Well, 120 minus 3. Probably didn't need the calculator on that one. Feig. There you go. So, and then not sports or a movie. Again, it's not either one of those. So 120 minus the sports. 18 sports minus the movie. 77. Okay, we're cruising right along. 3, a pet store has 25 pets, 16 dogs, and 9 cats. Of the dogs, 13 are puppies, and of the cats, 6 are kittens. A pet's chosen randomly. Again, look, we're only picking one pet. What's the probability? It's a dog, any old dog, puppy or adult. It doesn't matter. If you add it up, well, you don't even need to add it up. There's 25 pets. So that's your denominator, like every time. 16 of them are dogs. That does not reduce. How many are cats? 9. Pretty easy. How many are puppies? 13 are puppies, so 13 out of 25. Kittens, 6 are kittens. This one's really easy. A puppy or a kitten? Well, that would just be 13 puppies, 6 kittens. That's 19 animals out of the 25 animals. Not a puppy or a kitten. Well, if 19 of them are puppies or kittens, well, then what's 25 minus 19? 6. In other words, of all the animals, 6 of them are adult, whether a puppy or kitten. And again, just on that last one, if you want to, you can make that 24%. 24%. Just be ready that on a multiple choice question, you can be presented this, this, or this, and they are all equivalent, and they are all appropriate ways to show probability. All right, number 4 is about cars. The lot has 49 American-made cars, 26 foreign cars. So I'm going to put those totals on the bottom. And filling in this chart is going to help us. Of the American cars, 35 are white. Of the American cars. Okay. Of the foreign cars, 15 are white. All right. So a little math here. 49 minus 35 boop, is 14. 26 minus 15 is 11. It's going to help for you to have totals on this side too. Like how many cars were white? 35 and 15 is 50. How many cars were not white is 25. How many cars are in the entire chart? You can add these two, or you can add these two. Either way, it's 75. And it never really gave you that grand total in the directions, but that total is very important because it is essentially the denominator of many of our answers. Because how many cars are American? 49 out of 75. How many cars are foreign? 26 out of 75. How many are American or foreign? All of them. 100%. Or 1.0. Okay. How many are not white? Well, look at this chart, makes that pretty easy right here. Not white. 25. 25 out of 75 is a third, or 33%. American or white? Okay, now we have a little intrigue. American cars, we've got 49 out of 75. White cars, we've got 50 out of 75. And you might be looking at that going, wait a minute. That would be 99 out of 75. That's more than 75. And you're right, so that's not the right answer. Okay. We want to count American cars and white cars, but by doing that, look right here, I am double counting the 35. So whenever you're doing the probability of an or, A or B, you add up the probability of A and B. Oops. And then you always subtract the probability of A and B. And in this case, what's the probability of A and B? Is the probability of a white American car, which is the 35 right there. So you're subtracting the overlap. Essentially, I've always thought of it as if I add up these and I add up these, I have counted this group right here twice. And you just don't want to double count. So 49 plus 50 minus 35. So 64. Okay? And you could turn that into a decimal if you wanted. So, again, probability of A, probability of B, probability of both. And you subtract that one. F, foreign or not white. All right, we can use this same formula. Probability of a foreign car. All right, let me clean up my chart here first. Probability of a foreign car would be this, right? 26. 26 out of 75. Plus the probability of, all right, not a white car, which would be these cars, right? There's 25 of those cars. I'm going to highlight it. So that's 25 cars. Now, if you did that though, look at the chart. Where does my highlighting overlap? It overlaps right here. These 11 cars have been counted in both groups. So that's this part of my formula right here. You are subtracting the overlap. I've always thought of this as the overlap. Minus 11 cars are in the overlap. So 26 plus 25 minus 11 is 40. 40 out of 75. That does reduce, right? You could divide that by 5. 40 divided by 5 is 8. 75 divided by 5 is 15. And I don't think that reduces. 8 out of 15. Boom. So a little over 50%. All right, last page, second page. Marcy's mom puts a bunch of cookies in the jar. Zach doesn't know how to pronounce Marcy, by the way. Listen to his video. And 27 are chocolate cookies. Okay. So that would be down here, and 32 are vanilla. Whoops, 27 goes there, and 32 goes there. Of the chocolate cookies, 7 of them were generic. So of the chocolate cookies, the generic ones count was 7, which means that's 20. Of the vanilla cookies, 10 were generic. Okay, 10 and 22. That's 17 generic, 42 not generic. Adding up the totals either way will give us 42 plus 17 is 59 cookies. How many? Okay, part A. Again, a cookie, one cookie. The chance that it's chocolate is just 27. out of 59. Doesn't reduce. Vanilla, 32 out of 59. A chocolate non-generic. So this is being quite specific. Chocolate non-generic, right there. There's 20 of those cookies. Now, part D is not worded the same. This is the trick of probability. You have to know what it's asking. You know, this and this you could very easily read too fast and think they're asking you the same thing. Okay, this is a chocolate cookie or a non-generic cookie. So in my chart, where's my chocolate cookies? Well, that's these 27. Where are my non-generic cookies? That's these 42. So this is that formula I did on the previous page where you do 27 plus 42, and that would be 69 cookies. Okay? But that is counting this group right in the middle twice. These 20 cookies are being double counted. So 27 plus 42 minus the overlapping section. There are only 49 cookies in that count. 49 out of 59. Or another way to think about this is I want to count this, this, and this. There's only really 4 different kinds of cookies, right? I'm counting 3 of them. The only group that doesn't count are these 10 cookies. If you take 59 minus 10, look, you get 49. Another way. E is a vanilla generic cookie. That is specifically asking just about these 10 cookies. They have both characteristics. 10 out of 59. Then F, again, is vanilla or generic. Okay, so that would be, here's my vanilla. My generic go this way. Again, where does that highlighting overlap? It overlaps with the 10. So if I could add up, I could just add up these 3 numbers and I'd be good. I could do 7 plus 10 plus 22. Just adding the 3 numbers that are highlighted, that's 39. Or I could do 17 plus 32 minus the overlap. And look, they're both 39. So multiple ways to go about this. 39 out of 59. Pizza shop has 2 sizes of pizza, large and small. On a certain day, they made 59 plain pizzas. That's the total of plain. And 72 pizzas with toppings. Of the plain pizzas, 19 were small. 19 were small. And of the 72 with toppings, 42 were large. All right, we can just do a little math. 59 minus 19 leaves me with 40 of those. Because, right, these 2 have to add up to 49, or to 59. And then same reasoning, this would be 30. Adding this way gives me 82 large pizzas and 49 small pizzas for a grand total of 59 plus 72. Or if I did 82 plus 49, they're both 131. So this is the grand total. I feel pretty good about that. How many large pizzas are there? 82 out of 131. Small pizzas, 49 out of 131. With toppings, 72. Plain pizzas, 59. So these first 4 questions are really quite simple. Now, the next one has to be a large pizza and a plain pizza. That is just these right here, 40 out of 131. A small with a topping, well, that's these right here, 30. You can turn any of these into decimals or percentages. All right, here we go. Small, here's that word or again. Remember, it could be written like this. Small u, a u means or. Notation will get you sometimes. Small or plain, that's a way notation could look. So I could do it this way, small, 19 and 30. Or plain, 40 and 19 again. But I've already highlighted this 19, so I'm not going to do that. I'm just going to add up the 3 that I highlighted. That's one way to think about it. There were 89 pizzas that satisfy the criteria. Large or with a topping. So large, it's this and this, or they have a topping, would add the 30. I don't want to highlight this guy again, right? See how it's got darker there? I don't want to count the 42 twice. But here, to show you the formula way, I'll do this. There were 82 larges, that's this, right? So that's 82 out of 131. Plus, how many have toppings? That's 72. 72 out of 131. If you stopped right there, I hope you would realize, wait a minute, that's 154. That's more than the total. You can never have a probability above 100 more than the total. Doesn't work. So then you should be like, what did I miss? You did not subtract the overlap. The 42 is the overlap. And now when you subtract that, it brings it back down to a number that is realistic of 112. Small or large? Well, looking at this, it looks to me like all the pizzas were small or large. So 100%. 7. Over a 5-year period of time, 80% of the winter days, oh, these are percentages, 80% of the winter days in Philly had an average temperature above freezing. Okay, so that would be telling me this total is 0.80. And then it says 20% of those days had precipitation. Okay. 20% of these days, okay, had precipitation. All right. So this plus this has to be 0.80. So therefore this is 0.60. Below freezing, keep going. On the days with an average temperature below freezing, that would be these days, of those days, 15% had precipitation. Okay, that would be 0.15. And that would mean this would have to be the other 85%, right? 1.0 minus 0.15, 85%. Oh, sorry. That's wrong. That ain't right. What do these have to add up to? This covers all the different types of days, right? So these have to add up to 100 or 1.0. So what's 0.2 plus 0.6 plus 0.15 is 95%? So 1.0 minus 0.95 gives me the remaining, these days were only happen 5% of the time. 5% of the days were dry and below freezing. Adding up these, you get 20% of the days. This is good because look, that plus that is 1.0, which is good. That's all the days. 65% of the days were dry and 35% of the days had precipitation. All right, how many days were above freezing? 80%. How many days had precip? 35%. So I'm going to just keep these as decimals because that's what I'm being given. C, freezing with precipitation, is just asking you for these 15%. It's freezing, it's below freezing, so 15%. Freezing or, there's that or again. So freezing is 20%. 20% of the days are freezing, right here. Plus precipitation. Precipitation happened 35% of the time. That's from right here, those two. But when I add up those two, I have double counted this rectangle. So I subtract 0.15. 0.20 plus 0.35 minus 0.15. and that's 0.4. So 40% of the days. Okay. E, it doesn't use the word or. It just says above freezing, no precip. That is dry, right? No precipitation is dry. So that's 60%. F, above freezing or no precipitation. It's the word or again, right? So above freezing is 80%. No precipitation is dry. If you add up those two, you're over 100%. 0.8 plus 0.65. That's 145%. Then I have to subtract the overlap. The overlap is this box minus 0.60. So it's an 85% probability. All right, last page. Computer store. Has these computers, Dell, HP, and Macs. You're going to pick one computer at random. How many computers are in the entire chart? If you take your time and add all these up, there's 116 total. Okay? How many are Macs? 20 are Macs. 20 out of 116. You could take your time and reduce. I'm not going to do that on the video. A Dell or an HP, there's 39 Dells. There's 57 HPs. 39 plus 57 is 96. A laptop, if you add sideways, you get 57 laptops across. So 57 out of 116. D, Mac laptop. Only one box satisfies both of these conditions. The Mac laptop, there were only 12 of those. Every once in a while, I like to just do this for kicks. So that's about 0.10. So that's about 10%. A Mac or a laptop. How many Macs did we have? 20. Plus laptops, we had 57. And again, that would be adding up these plus these. But look what I double counted. I double counted the 12. So 20 plus 57 minus the 12. There are 65 machines that qualify for what I'm asking out of 116 machines. Notice that these denominators are all the same, right? All right, D, a Dell or a desktop. How many Dells are there? 39. How many desktops? Oh, I haven't added those up yet. Desktops are this row, which are 59. But when I add this plus this, I have double counted. What have I double counted? The 19 right here. That's the overlap that I subtract. 39 plus 59 minus 19. And there, 79 out of 116. All right, next one. Class has 30 kids. They've filled out probably one of those forms where they force people to fill in the bubbles. Are you white, Asian, African American, so on. Those surveys aren't perfect. You know, they force people to choose. But they have to choose one, right? Or they opt out. These students have either black hair, brown hair, or blonde hair. There's the chart. This one, we just have to fill in the totals as we go. I look at this. This is where my eyes go right away. So I can tell this has to be a 2. To be 8 plus 2 is 11. You could have also, I guess, gotten here first. 2 plus 1 is 4. 4 students had blonde hair. I guess you could have also just started here. 1 plus 7 plus 2 is 10. Okay. You can really go lots of ways from here. How about this? 7 plus 2 is 9. You would need 5 more to get to 14. 10 plus 11 is 21. So this circle's got to be 9 so that I can get this row to add up to 30. How about up and down? 5 and 1 is 6, leaving you 3. And the last one, you can either add sideways. add these, or you can do 30 minus these. Either way, you're going to get 12. All right, filled in correctly. We are still picking one student. A student is chosen. It does ask us here, are they disjoint? Okay, meaning disjoint are events that cannot happen together. Okay, so can you pick a white student or an African American student? Since it's the word or, it's one or the other. Okay, so yes, you can. There are 10 white students and 11 African American, so 10 and 11, there's 21 out of 30. And yes, that would reduce, but these are disjoint, meaning there is no overlap between these groups because in the survey, people had to pick one. B, a student without blonde hair. So again, notation-wise, this could be blonde hair with a C, meaning not blonde hair. So that would be black or brown hair, which is 26 people. 26 out of 30. C, an Asian student with brown hair. Asian with brown hair. So where are the kids that have both of those characteristics? Right here. Okay. D, a student who is either Asian or had brown hair. So Asian students, we have 9. Brown hair, we have 14. That would be 23, but this is one of those ors again. Remember, whenever you have or, you have this group right here, Asian column. The brown column is here, and they overlap on the 5. So you don't want to double count those kids. So you do 9 plus 14 is 23, minus 5 is 18. 18 out of 30. Right? This is, again, formula-wise, this is like probability of A plus the probability of B minus the probability of A and B. I guess technically, right, they're all fractions. They're all out of 30, out of 30, out of 30, but that's really all we do is focus on the numerators. E, a student who is either African or has black hair. So again, this is the same formula I just talked about. So let's clean this up. African students, according to the chart, is 11. Black hair is 12. The overlap is 8. So 23 minus 8 is 15 out of 30. So that's half. Half the kids. F, a student who is either African American or Asian or has black hair. Well, there's 3 ors. Holy Toledo. So how about this? Just let's count the people in the chart that have one of these things, because or means one of these characteristics or both or all 3 in this case. So let's highlight them. African American. B. Okay, I want to start fresh. African American is the 8, the 2, and the 1. There's 11 of those, okay? Asian, 3, 5, and 1. So far I would add up those 6 numbers. Or they have black hair, okay? Which is this row, but I've already counted this and this, so I really don't want to do it again. So I'm only really going to add the 1 in. You know, if you double count this, you can see it's being highlighted twice, and the 3 would be highlighted twice. So really, I just want to take all of these 7 numbers and just add them up and not count anybody twice. 1 plus 1, 21 kids. 21. I guess back to this idea of determine if they're disjoint. Are these disjoint? Disjoint means they can't happen at the same time. Well, black hair can happen at the same time as these, so it is not disjoint. These events are not disjoint. G, which ones are disjoint? Can you be white and Asian at the same time? Well, in practicality, there's probably a lot of people that would say they're kind of a mixture of both. But in this chart, people were only given one option. So yes, they are disjoint in this chart. Brown and blonde hair. Can you have both colors hair without dyeing your hair? Can you naturally be brown and blonde at the same time? I don't know of anybody that is. They're disjoint. Not white and not blonde. Is there a possibility somebody could be both? Sure. Not white, for example, could be African American. Okay. And not blonde could be black hair. Can somebody have both of those things? Yes. So this is not disjoint. They can both happen at the same time. Okay? All right, folks.